All right, ladies and gentlemen, welcome to our lesson about conditional probabilities. So this is a vocab term you need to know. You need to know that conditional is not the same thing as compound, which is actually going to be our next lesson. But conditional probability means you know one of the bits of information already. And an example it gives here is like you can flip coins and roll a die. Like flip a coin and roll a die, and you can say, oh, I want the probability of rolling a 6 given that the coin landed on heads. Would mean you already flipped the coin, you know it was heads, and then what's the probability of rolling a 6? That's different than what's the probability of rolling heads, flipping a coin, getting heads, and rolling a 6. Those are different statements, and you have to be very careful when you're figuring these out. And so it's got some notation involved in it. It looks like this: A and then vertical line B. That means A given B. That means you're trying to find the probability of A given that B has already happened. And so one of the reasons why it's called conditional is because something has happened already, and that's going to change your probability. And there's a formula for figuring it out. It's just if you want the probability of A given B, you get the probability of A and B and divide by the probability of B. And you'll see an action here on our first problem. But this means probability of A given B, meaning what's the probability of A given that B already happened. And so we're going to use our first example here. We got a lovely table, some cupcakes with a white and blue frosting. There's vanilla and chocolate cupcakes. It's super exciting. Hopefully you're eating well where you are now. And if you're not, you should really look into that. Anyway, our first one here, and what's the probability of vanilla given it's blue, like got blue frosting? And so the way to figure that out, you're going to get the probability of vanilla and its blue frosting over the probability that it's just blue frosting. Which is going to give you, probability of vanilla and blue. We got vanilla and blue, which is going to be these 5 here. So it's 5 out of the 21 that are vanilla and blue. And then the bottom one, the probability it's got blue frosting. Well, there's 12 total that are blue frosting out of the 21. And so we got 12 out of 21. This gives you a lovely complex fraction, which is not so nice. But luckily, dividing by a fraction is easy as pie. Just flip the second and multiply. Someone said that once. And yeah, anyway, you flip it upside down. It's 21 out of 12. The 21s are going to cancel, and it's going to give you 5 12ths. Ta-da! We got it. The probability that the cupcake is vanilla, given we know it has blue frosting. There's 5 of the 12. And let's try out this next one. What's the probability it's got white frosting given it's chocolate? Well, you need to first get the probability that it's white and chocolate. So we got chocolate and white is this box here. Let me erase that one. And there's 6 out of the 21 that are vanilla and chocolate. And then on the bottom there, we're going to do 13 out of the 21 because 13 are chocolate out of the 21 total. And again, you're going to have to flip the second and multiply, which is going to turn this into timesing by 21 13ths. Those are going to cancel, and you get 6 13ths. Now that we've done a couple of these, I wanted to hopefully get you to notice that our probabilities had just been look at the number that are chocolate and how many are white, right? You got 13 chocolate. How many are white? You got 6. 6 out of 13 are white. This one here, how many are blue? And of the blue ones, how many of those are vanilla? And so you count that there's 12 blue and there's 5 vanilla, so it's 5 12s. Which, yeah, you can kind of go straight to your answer. So this one here, what's the probability that's got blue frosting given as chocolate? Well, you go to your chocolate one and you figure out how many are blue frosting, and that's 7 of the 13 cupcakes. Well, that kind of makes you wonder, why the heck does this equation even exist then, if we can just figure that out by looking at the table? Just look at how many are chocolate and count number white. Well, that's going to kind of be answered later when you have problems where you don't have all 3 bits of information already. Like you may only know this, and you won't have a whole table that has all the information for you. And so this exists because sometimes you're not given all the information. Say you don't have the inside stuff, and you have to figure out what it's going to be, and that's kind of what it is, and that's why that equation exists. But if you don't need it, then don't use it. For example, example 2 here. We're not going to really need that formula to figure this out. Basically, when you get to your assignment, that's really where you're going to use that information. Kind of use the equation to find unknown things. But yeah, here we got this example. We got technology use in Miss K's third period. I love how it's iPods and then cell phones. You can definitely tell this is like from before those were the exact same thing, which we just call iPhones now. But yeah, you know, I like how people try to be like modern and then things get dated really fast. Anyway, if you're going to figure out any of these probabilities, you do want to know what the total is, which you do 4 plus 10 plus 15 plus 6. You just add them all up. We're looking at what was that, 35? 35. All right, 10 plus 15, 25 to 29. Okay, 35. And now we can go through here and figure out our probabilities. What's the probability that they have an iPod given they have a cell phone? So you're going to look at these cell phone users, which you do need to figure out how many there are. There's 25 of them. And then figure out what portion of them also have an iPod, which is going to be 10. So 10 out of those 25 cell phone users have iPods, and that does reduce a little bit. They're both divisible by 5, so you get 2/5. Next one. What is the probability that they have a cell phone given they don't have an iPod? So you gotta look at the non-iPod people. That's these people here. You got 6 plus 15. That's gonna be 21 of them don't have an iPod. And then you have to figure out what portion of those have a cell phone. Well, there's 15. And voila, we have our lovely little probability there. And you can reduce that. Those both are divisible by 3. So you get 5/7. So we're doing pretty good here. I want you to try out the last one. Pause the video, take a moment to get that last one, and we'll go from there. Did you get it yet? Did you get it? All right, okay, give me a sec. All right, you can check now. So if you count number of people with no cell phone, that's going to be these 6 plus 4 people. There's 10 there. And then however them have an iPod but no phone, it's going to be 4. So there's 4/10, which reduces to be 2/5. So there you go. That's kind of that example there. So they're pretty quick. If you know how many are in each of these groups, you can usually figure out the conditional probability pretty quick. But yeah, it's mainly an exercise of making sure you know what the notation means. And then we got one more thing. I'm going to pause the video till this helicopter goes away. Alright, so the last thing is we're trying to figure out if events A and B are independent or not. A lot like previous lesson, except if you're given some conditional probabilities, it's got a slightly different setup. So 2 events are going to be quote-unquote independent if and only if the probability of A given B is the same as just the probability of A. We're going to use this little table as an example so you can see it. And so, we're going to get the probability that is got blue frosting given it's vanilla, and see if it's the same as just the probability of having blue frosting. We just need to figure out if those are the same or not. So, first one here, figure out how many are vanilla, so there's 8. Figure out how many are blue frosting, there's 5. And so 5 out of the 8 have 5 of the 8 vanilla cupcakes have blue frosting. And then you have to figure out what's just the probability of any cupcake has blue frosting. Well, there's 12 of them out of the 21 cupcakes. So 12 out of the 21. You need to figure out if these are the same or not. Take a moment to put them in the calculator so you can get the decimal representation and figure out if they're the same. So pause the video, go ahead and do that. And that's how you check. You should have gotten on the left side here 0.625. And on the right side, you should have gotten 0.571. These are not the same. And since these probabilities aren't the same, these are not independent. And so right there, they are not independent. And voila, there's your examples from your assignment. Next up, I'll be making the video about doing some worked examples from your assignment so you can have a little bit extra help there if you need it. Good luck.